Today we're going to look at 1.7, 1.8, and we'll start here with the bell work. So if you ever need to pause or want to fast forward or whatever, you can do that. So pause this here and see if you can work through this bell work question. A group of friends decides to buy a vacation home for $120,000. If they can find one more person to join them, each person's contribution will drop $6,000. How many people are in the group? So this is one that we looked at the other day in notes. So if we're paying with just the original group, we've got 120,000 divided by X. And that's how much the original group, how many in the maybe should say original group should pay. That's 120 divided by X. Well, that price is going to drop, so subtract by $6,000. And that new price will be the same as if they find one more person. So that would be 120 or 120,000 divided by your X plus the one person. If we go to solve this, we're going to go ahead and multiply by our common denominator, which would be X plus 1. Then we're going to take and multiply, so we have 100, and my X cancels here, so we have 120 X plus 1 minus nothing cancels here, so we have 6,000 X plus 1 equals, here my X plus 1 cancels and I get 120,000 times X. So we're still going to just distribute things out. So we get 120,000 X plus 120,000 minus 6,000 X squared minus 6,000 X equals 120,000 X. So we do have a quadratic here. But you may also notice that everything here is divisible by 6,000. Also, your 120,000 X here cancels with the 120,000 X there. And then I can go ahead and divide everything by 6,000. Now I'm actually going to divide by negative 6,000 because I want my X squared to be positive. Okay, so that creates an X squared. Here I have a plus X. And then I have a minus 20 equals 0. So when I factor this, I need factors of 20 that subtract to 1, which are 5 and 4. Signs are different. The bigger one's positive, so that's X minus 4, X plus 5. So X is 4 and minus 5. Well, you can't have negative 5 in a group, so your group originally started with 4 people. Okay. So if you found a fifth person, that would drop the cost by $6,000. But with the 4 people, your cost would be $30,000. So we're looking at $30,000 with 4 people, or 24,000 with 5 people. Okay. But it just asks how many people were in the group. The answer to that is 4 people. Okay, 1718, solving inequalities and absolute values. So the goal here is to review properties of inequalities and apply them to equations including absolute values. Okay, there's one really important thing with inequalities, and that is when you multiply or divide by a negative, you must flip the direction of the sign. Okay, so if it was greater than equal to and you divide or multiply by a negative, you're going to have a less than equal to. You just flip it over. We can actually say that we do this with an equation, but when you flip an equation, it's the exact same thing either way. So we don't notice it, so we don't talk about doing it. Okay, so solve the inequality here and sketch the solution set. So again, I'm going to solve it like a normal equation. But if I multiply or divide by a negative, we have to flip the sign. So I'm going to subtract 9x here first. So I get negative 6x less than 4. We're going to divide both sides by negative 6. So you get x greater than negative 2/3. Okay, and it wants us to sketch this solution set. So if I graph this out, here's 0, here's negative 2/3. We have an open circle, and I want x to be greater than that number, so we're going to the right. So in order to write this, we would write this as interval notation. We're going to have a parenthesis at negative 2/3 because you can't actually have 2/3, to infinity with another parenthesis. So here's our interval notation for that. Okay, and we can have like a 3-sided inequality here. So this value is in between these two. And we solve it the same, but what I do to one side, I'm going to do to all 3 sides. So I'm first going to start by adding 2 to all 3 sides. Whoop. So 6 less than equal to 3x less than 15. And then we'll divide everything by 3. No need to flip the sign, either sign. So you have 2 less than equal to x less than 5. And we'll go ahead and write this as an interval notation. Here, if we want to graph it out, you don't always have to graph it out. So we're at 2, 5, here's 0 over here. Okay, I can have 2, so that's a closed circle. I cannot have 5, so that's an open circle, and we're in between the two. Okay, so that's a bracket 2, comma 5. Okay, you cannot have 5, that's why it gets a parenthesis. You can have 2, that's why it gets that bracket. Okay, I do want to talk about one additional thing here. We talked about flipping the signs with the negative. If you have something, let's say this was negative 6 less than equal to 3x less than 15. Okay, and I'd go and divide by 3. I don't flip the direction of this sign because this is negative. It's only if you are dividing by a negative number. Here, I'm not dividing by a negative number. I'm dividing a negative number, but I'm not dividing by a negative number. So make sure you understand the difference of when you're dividing by a negative. If it looked like this, here, and now I'm dividing everything by -3, now I'm flipping the direction of the sign because I'm dividing by a negative. Okay, so a quadratic inequality. Okay, again, with any other inequality, we get everything to one side. So I'm going to move everything to the left here so that this is positive. So I have x squared minus 5x plus 6 less than or equal to 0. Go ahead and factor if we can. So factors of 6 that add to 5 is 2 and 3. Signs are the same, they're both negative. So x minus 2, x minus 3. So you get x equals 2 and 3 here. So we're going to plot this on a number line. Okay, here's 2, here's 3, zeros over here. We can have 2 and 3 because right here it has the equal sign. So we're going to put a closed circle here and a closed circle here. Now I have 3 windows or 3 ranges of numbers. I have this range over here. I have this range in between 2 and 3, and I have this range here. So there's a couple ways you can go about solving this. Probably the easiest for most people is to pick a value in each window and see if it's true or false. Okay, so we can pick a value. We can pick a value of 0 here and plug it in and see what happens. Okay, so if I plug 0 in, this goes away, and you have 6 less than or equal to 0. Well, 6 less than or equal to 0 is false, so we put a false here. Okay, now this is a parabola, so it's going to cross at both of these spots. So if this is false, it's actually going to alternate this parabola. It doesn't, as we get into higher degrees, it doesn't always alternate. But this one, parabolas will alternate. So true and then false. Okay, if we pick, we can pick 2.5 here. Okay, so 2.5 squared minus 5 times 2.5 plus 6. It needs to be less than or equal to 0. Well, 2.5 squared is 6.25. 5 times 2.5. That'd be negative 12.5 plus 6 less than or equal to 0. 6.25 minus 12.5 plus 6 is negative 0.25 less than or equal to 0. And that is true, which is why we got the true here. And you can try any number you want, like 10 or some easy number that you can square. 5. So if you get 5 squared minus 5 times 5 plus 6 less than or equal to 0, well, that's 25 minus 25 plus 6 less than or equal to 0. Those cancel, you get 6. That is not true. Okay. The other way, so that's one way you can figure out. And here, I want my answer in the true region. So here my answer would be bracket 2 comma 3. Oop, that's also a bracket. Okay. That's one way you can look at it. I like to personally look at the direction the parabola opens. So we solve it again, and I know it's 2 and 3 with closed circles. I look here at my leading coefficient, it's positive. When that is positive, it tells me that my graph is going to open upwards. So my parabola is opening up like this, okay? And this sentence right here tells me this left side is my parabola, less than equal to 0. So I want to know, when is my parabola less than equal to 0? Well, this number line here is 0. Okay, so if I look at this number line, I want to know, when is my parabola below that number line, which would represent less than 0. Okay, because you could have your y-axis here. You could have your y-axis there. And I want to know, when is that thing below 0? Well, it's below 0 between 2 and 3, which matches your answer there. Okay, so you don't necessarily have to pick numbers in between each window. Now, when we get to higher ordered polynomials, yes, we're going to have to pick numbers in each range because we could bounce, and it doesn't have to alternate all the time. Yeah. All right, here's another one. So again, we're going to move everything to the left side. So 2x squared minus x minus 1 greater than 0. See if we can factor this. So we'll take 2 times 1 is 2. Factors of 2 that subtract a 1 are 2 and 1. So we're going to have a 2x and an x. I need 2 and 1, so these have to be 1 and 1. Signs are different. The bigger one is negative. So it does matter here which one of these ones is negative. It's going to be this one, and this one's going to be positive, because your 2 times this one has to be the negative. So this tells me that x equals negative 1/2 and 1. So if we put this thing on a number line, here's negative 1/2. Here's positive 1. It is not equal to, so these are both open circles. And my leading coefficient is positive, so my parabola is going to open upwards. And I want my parabola when it is greater than 0. So I want it when it's above this blue number line, which is when it is less than negative 1/2 and greater than 1. So that's negative infinity to negative 1/2, union 1 to infinity. Again, we could pick values in each window. So here I might pick 0 and plug that in. So 0, this goes away, negative 1 greater than 0. Oh, sorry, 0 is not there. I could pick negative 1. 0 is here, which would be false, because you had negative 1 greater than 0. Here I could pick something like 2. So if we pick 2, so 2 squared minus 2 minus 1. So 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. 6 minus 1 is 5 greater than 0, which is true. And with parabolas, they do alternate. So you have true on the outsides, which matches with this window right here. Okay. Okay, now this one is a higher ordered polynomial. It's already factored out for us. Okay, so I know that x equals 0, x equals 1, and that actually has a multiplicity of 2, and x equals 3. Now, I don't know if you remember about graphing, but with a multiplicity, an even multiplicity, that graph bounces at that point. But we're going to look at some test values here just to look at what happens. Okay, so 0, 1, and 3. And we cannot, it's not equal to, so we cannot have those. So they're all open circles. And here I have a window here, 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 and here. So I actually have 4 different windows to test out. All right, so if we just choose a number in each window, so I'm going to choose -1, I'm going to choose a half, we can choose 2, and we can choose 5. It doesn't matter as long as those numbers are in that window. So when I plug -1 in here, okay, we can look at the signs that would be created here. So if I choose -1, let me just, I'll write it above. This would be negative, okay? If I choose -1 and plug it in here, well, a negative minus a negative is some negative number, but you're squaring that negative number, so it's going to be a positive. It ended up being -2. -2 times -2 is a positive number. If I plug a negative into here, or the -1 into here, a negative minus 3 would still be a negative number. Okay, well, negative times a positive times a negative is going to be a positive answer because your negatives cancel out. So this would be a positive answer, which is not less than 0. So this here would be false. Okay. Now, if we look at our next window with a half, okay, I know that looking at the signs may be a little bit confusing, but if you want to plug the number in, by all means, you could do that. So x minus 1 squared, x minus 3 less than 0. Okay, if I plug in a half here is positive. Let me change colors for you. A half minus 1 is negative, but the negative squared would be positive. In fact, this x squared will always be positive because you're squaring it. And then your half minus 3, that's going to be negative. Well, positive times a negative is a negative, and that negative answer will be less than 0. So this is true. This was false. This is true. Again, with higher order polynomials, it may not alternate, okay? So I have false, true. This next window here may be true or false, okay? So I'm going to rewrite it. X minus 1 squared, x minus 3 less than 0. If we plug in 2, this would be positive. The squared would always be positive. And then 2 minus 3, that's negative. So that's negative. So positive times a negative is a negative, which is less than 0, which is true. Okay. And then 5. So you see it didn't alternate. We went true, true. So x minus 1 squared, x minus 3 less than 0. So 5 would be positive. The squared is always positive. And then 5 minus 3 would be positive. So this would all be positive. Positive times a positive is greater than 0, which is not what we want. So this region would be false. So what we want here is 0 to 1 union 1 to 3. Do not write 0 to 3 because you cannot include 1. So you have to have a union there. Now, we can still look at this graphically if you know kind of some end behaviors of higher ordered polynomials. Okay, this is x squared x. So that's x to the fourth. X to the fourth end behavior goes in the same direction. And because my leading coefficients, or my leading coefficient would be positive, they open up. Okay, so my graph here would actually say start up. We're going here. We're going here. With a multiplicity of 2, it bounces. So here at 1, we're actually going to bounce. We're not going to cross. We're just going to bounce. So it's going to hit it and bounce off, and then come to 3 and go up. And you want to know when it's less than 0. Well, in this section right here, it's below the line. And this section right here, it's below the line, which matches the sections or the intervals that I put for the answer and that are true. Okay, so you don't have to be able to do the graph. You just have to be able to choose one of the methods here and work through it. So we've got 3 different kind of methods here that we've talked about. We've talked about plugging in numbers in each region. We've talked about just looking at the signs in each interval, and we've talked about looking in the graph. Okay, so solving with a quotient. Okay, so I'm still going to get everything to one side, and my goal is to get one fraction on the left. So we're going to start by subtracting the 1. So 1 plus x over 1 minus x minus 1 greater than or equal to 0. We need a common denominator here to add these, which would be 1 minus x. So 1 is 1 minus x over 1 minus x. Now I can subtract those. So I get 1 plus x minus 1 plus x all over 1 minus x greater than or equal to 0. If we combine things in the top, your 1's cancel. You get 2x over 1 minus x greater than or equal to 0. Okay, so a few numbers here that we need to look at are 1, because here at the bottom, I cannot have a 1. Okay, so x cannot equal 1. Okay, and we are equal to, so we find the zeros from the top. Okay, so this 1 will create an open circle. So if I look at my graph, here's 1. That's an open circle because I cannot have that because it was on the bottom. I want the zeros from the top, the numerator. Okay, so x equals 0 from the top. Okay, so, and it is equal to, so I can have that. So we're going to put 0 with an open circle. That's where my graph will cross the x-axis. Okay, and we can pick some values and plug them in, or look at the positive, negative signs. So let's look at -1, 1/2, and 2. So if I look at, we're going back to the original to plug it in. So that's 1 minus, or 1 plus -1 over 1 minus -1. Is that greater than or equal to 1? Well, 1 plus -1 is 0. 0 divided by anything is 0. 0 is not less than, so this section here is false. If we plug in a half, 1 plus a half over 1 minus a half greater than equal to 1. Now, I like plugging it back into the original. Some people will plug it down here and look at the signs. Okay. You can plug it into either one if you would like. Hopefully you didn't make any mistakes going through here, though. I'm a fan of plugging it into the original because I don't look at signs. I look at the actual numbers. So this is 1.5 divided by 0.5, which is 3. 3 is greater than equal to 1, so this is true. If I plug in 2, 1 plus 2 over 1 minus 2 greater than equal to 1, that is 3 over negative 1, which is negative 3, which is not bigger than equal to 1, so this is false. So your true region is your answer. So that is 0 to 1 with a parenthesis on the 1 but a bracket on the 0. Okay, and that means I can take any number in between here and plug it into this original equation and it will be true. Okay, a carnival has 2 plans for tickets. Plan A is a $5 entry fee and 25 cents per ride. Plan B is $2 entrance fee and 50 cents per each ride. How many rides would it have to be for Plan A to be less expensive than Plan B? So I want to know, when is Plan A less than Plan B? Okay, so if I find, these are just linear equations here. It's 25 cents plus $5. And this one is 50 cents plus $2. Okay, so I'm going to plug Plan A in, which was 0.25x plus $5 less than 0.5x plus $2. So if we subtract 0.25x, subtract 2, we get 3 less than 0.25x. We're going to divide both sides by 0.25. And we get x equals 12. Well, we get 12 less than, or greater, less than x. So x greater than 12 rides. So if you do more than 12 rides, Plan A will be less expensive. Okay. So more than 12 rides, Plan A will be less expensive. Okay, graphically, we could look at this. Okay, and these aren't exact graphs, but one of them might look like, let's say they both have positive slope. One might look like this, and the other one might look like this. This point is 12. Right there. Okay, that is when Plan A becomes, well, this would be Plan A. Plan A becomes less expensive than Plan B. Okay, but before that, you want Plan B, but after that, you want Plan A. So you kind of need to know how many rides you're going to be looking at riding. Okay, the instructions on a bottle of medicine indicate that the bottle should be stored at a temperature between 5 and 30 degrees Celsius. What range of temperature does it correspond on the Fahrenheit scale? So something you need to know is that Celsius equals 5/9 Fahrenheit minus 32. I know the range is between 5 and 30. Okay, well, I'm going to take this C value and plug it in for the Celsius here. So 5 has to be less than 5/9 F minus 32, less than 30. Okay, so there's a couple things you could do here. You could distribute the 5/9. I think that would be more work. Or you can take each side and divide by 5/9. Or multiply by 9/5. It's the same. Okay, so then you're going to get 9. 5 times, or 5 divided by 5/9 is 9. Less than F minus 32. Less than 30 divided by 5/9 is 54. And then just add 32 to each side. So you get 41 less than F less than 86. So the medicine here should be kept between 41 degrees Fahrenheit and 86 degrees Fahrenheit. Okay, so now we're going to move on to absolute value, which is section 1.8 in the textbook. And with absolute value, if you have some absolute value, let's say absolute value of x equals a, some number, okay? Or we'll use n for a number. Now, no matter what this value is, this value over here will always be positive. So your x here could be a positive x, or it could be a negative x. For example, if I have the absolute value of x equals 3, that means that this x value right here could have been a positive 3, or it could have been a negative 3. We don't know which one, so we're going to assume that it's both. Or not both, but we're going to assume either one. So we solve absolute value equations by splitting it up into a positive and a negative. Okay, using the definition. The definition of absolute value says the absolute value of A equals A if A is greater than or equal to 0, and negative A if A is less than 0. Okay, which says that this value in here can be positive or negative. And that's what we're going to use. Okay. So, solve this equation. Now, this value in here could, in order for it to be a positive 3, this whole thing could be positive. So 2x minus 5 equals 3. Or this whole thing in here could be negative. So negative 2x minus 5 equals 3. Now, some teachers, and this is totally fine that they do this, some teachers will teach you to change the sign of the solution out here. I don't do that, and the reason being is with inequalities. If you change the sign of the answer, you have to remember to flip one of the signs of the inequality, and I don't like trying to remember that. But if we change the sign of what's inside of the absolute value, which is really where the sign change occurs, we don't have to remember to flip the sign. And we'll see that here in a little bit with the inequalities. But if you want to do that and you want to solve that way, I'm totally fine with it. So we're going to solve each one of these. So I'm going to add 5 here. So 2x equals 8. Divide both sides by 2, and you get x equals 4. Here we can distribute the negative. So you have negative 2x plus 5 equals 3. We're going to subtract the 5, so negative 2x equals negative 2. And divide by negative 2, so x equals 1. So you have a 1 and 4 are your possible solutions. And you can definitely plug those back in and check. Okay, here I'm going to isolate my absolute value before I split it up. So we're going to subtract 5. So 3x minus 7 equals 9. Divide both sides by 3. So you get absolute value of x minus 7 equals 3. So you have x minus 7 could equal 3. And you have x minus 7, that could be negative equals 3. So here x could equal 10. So negative x plus 7 equals 3. If I subtract 7, negative x equals minus 4. And x equals 4. So your solutions are 4 and 10. So now we have absolute value with inequalities. Okay, I don't change anything I do. Okay, so we can have both the positive and the negative. So I could have that x minus 5 is less than 2, or negative x minus 5 is less than 2. So I change the sign of what's inside here. Okay, so here we're going to add 5. So x is less than 7. Or if I distribute it, or you can divide by negative first if you want. So you have x. Most of you, if you change the answer or you change the sign of your answer, you would end up dividing by negative first. So x minus 5 is greater than negative 2. This is what you would end up with, which is fine. Then we can add 5 out of that. So you get x greater than 3. And if we look at this graphically, we have 3, 7 zeros over here. We have open circles because it wasn't equal. And x is greater than 3 but less than 7, so we're in between. Okay. And 5 is actually my in-between part. Okay, if we look at the absolute value graph, 5 is in between. I would end up going down to, and it looks like this. Okay. That's where my absolute value would be. And I want it less than 0, because if I take this here, I say the absolute value of x minus 5 minus 2 less than 0. If we make it to 0 like we did with the other inequalities, this went right 5 and down 2, and I want to know when it's less than 0. Well, it's less than 0 in between those two things. So my answer here would be 3 parenthesis, or parenthesis 3 comma 7 parenthesis. Yeah. Okay, so here we're going to say 3x plus 2 is greater than equal to 4, or negative 3x minus 2 greater than equal to 4. And I sometimes just go ahead and distribute that negative in my head. I change the sign of everything there. So we're going to subtract 2. So 3x greater than equal to 2. Divide by 3. So x is greater than equal to 2/3. Add 2. So negative 3x greater than equal to 6. Divide both sides by negative 3. And now we're going to flip the sign. So x less than equal to negative 2. So Sometimes graphing it helps you set up the interval. So you got -2 here, 2/3 here. Close circles because they can equal. X is less than -2, but it's going to be greater than 2/3. So we're looking at that. So we have my interval on this one would be -infinity to -2 bracket, union, because I got to make this big jump, bracket 2/3 to infinity. Okay, so you can have two separate parts of an absolute value because I want to know when the distance is greater than 4. Okay, I want to know absolute value is a distance. I want to know when this distance is greater than 4. Well, out here and out here, that distance will be bigger than 4. Okay, and a word problem here. So the specifications for a car engine indicate that the pistons have a diameter of 3.8745 inches with a tolerance of 0.0015. This means that the diameters can vary as much as 0.0015 and still be acceptable. So find an inequality, including absolute values, that describes the range of possible diameters of the pistons. Okay, so let's say we measure the piston on our vehicle. That piston, that diameter is going to be D. Okay, we are going to subtract it with what they should have. Okay, they should have a 3.8745 diameter. And we're going to do the absolute value of that to get a positive answer because my tolerance is 0.0015. And it needs to be less than equal to 0.0015. Okay, so that tolerance that I found in mine has to be less than 0.0015. The absolute value, again, just changes it to a positive number. If it was negative, it would change it to a positive. So now we're going to solve the inequality. Okay, so we can solve it as a two-sided inequality. Okay, if it has a tolerance with this absolute value of 0.0015, it could be that we have a negative 0.0015 or a positive 0.0015. So if we have a negative 0.0015, this is kind of a secondary way of solving these. This tolerance has to be greater than that. So we'll say less than equal to D minus 3.8745. But it also has to be less than equal to the positive tolerance. Okay, and then I'm going to add the 3.8745 to all three sides. Okay, so they cancel here. So your diameter needs to be greater than equal to 3.8730, but less than equal to 3.8760. So, and that's in inches. So your diameter needs to be between both of those for it to be within tolerance. All right, that is all the notes we have for 1718. And you will have your assignment on the WebAssign. So if you have questions, feel free to reach out and ask them.